Hey guys, it's Alyssa. My group is doing sets of numbers, so here is our video to show you how to do sets of numbers. The first set we have is all real numbers. What represents it looks like the letter R. And it's easy to remember because all real numbers is an R. Then we have terminating or repeating decimals. The letter that represents that is a Q. Then we have positive and negative whole numbers that also can be integers. The letter that represents that is a Z. Now, when you write these letters, you can't forget to write the extra line, depending on what letter you're writing. Then we have positive whole numbers. It looks similar to an N, and it has that extra line right here. And it's easy to remember because whole numbers, N for whole. Then we have regular whole numbers, and it's shaped like a W. We also have irrational numbers, which is shaped like an I, and it's easy to remember because irrational is an I. Irrational numbers, a number that cannot be written as a quotient of two integers. Irrational numbers cannot be repeating nor terminating. So for example, an irrational number can be pi. It can also, which is equal to 3.14 and a bunch of other numbers that I forget. But as you can see, it repeats, and that's an irrational number, so this is not a whole number, nor a regular number. Another example of an irrational number can be the square root of 2. See, if you were to find the square root of 2, it would come to a bunch of random numbers, so that is not a rational number. Real numbers are the sets of all rational and irrational numbers. So, you have your whole numbers, which are the W. You also have your integers, which is the Z. Then you have your rational numbers, which are rational numbers are a Q, and then you have your all real numbers, which is the R, and irrational numbers for I. See, anything that is an integer is also a whole number. Anything that's a rational number is also an integer and a whole number. All of these and these are both real numbers. Irrational numbers are also considered real number because they're numbers. In the next slide, I will show you a couple of examples on how to understand rational and irrational numbers, all of the sets of numbers as well. Okay, for the first example, tell whenever each of the following numbers is a real number: a rational number, an irrational number, an integer, or a whole number. The examples they give you is the square root of 24. Okay, the square root of 24 is 4.898979486. The next example they give us is the square root of 100. The square root of 100 is 10. Then we have the square root, a negative square root of 81. The negative square root of 81 is negative 9. Now, I was able to find my results by dividing. And see, I couldn't do this in my head, so I had to use a calculator for the first one. But the square root of 100 is 10 because 10 times 10 equals 100. So, and the negative square root of 81 is negative 9 because 9 times 9 is 81. And no matter what, because in the beginning of the sign there is a negative number, you have to remember to bring it back to the end of your equation. Now, the answers for this is that 24 is a real number because it is equal to 4.8989 repeating. It isn't a rational number because it goes on and on forever. It is irrational number because it continues. It is not an integer, and it is not a whole number because you can't have 4.8989 repeating of something. A square root of 100 is a real number because it is equal to 10. It is also a rational number because it's a whole number. It is not irrational, therefore it's rational. It is also an integer, and it is a whole number. The negative square root of 81 is a real number because no matter if it's rational or irrational, they are all real numbers. It is a rational number because it is equal to negative 9. It's not irrational. It is also an integer, but it is not a whole number because you can't have negative 9 of items. Okay, so our next example is to order the numbers from least to greatest. We have 4 over 3, negative square root of 5, the square root of 13, negative 2.5, and the square root of 3. Okay, so I'm going to let you guys solve this on your own. So as you're solving it, just pause your video, and after you think you've got the answer, just replay and I will help you guys figure it out. Okay, so I'm going to explain how to solve this. If you don't have this answer, I will explain exactly how to get it. So you're going to make yourself a number line. You're gonna make yourself a number line, and you're gonna plot your first known point, which is 4 over 3. See, 4 over 3 would be 1 1/3. So I'm just gonna put that right here. I'm gonna label it. So then you have your next one, which is negative square root of 5. Negative square root of 5 is equal to negative 2.24. Right. So you can find that by using a calculator because it is very complicated to solve in your head. So you're going to plot that right here. So negative square root of 5. So that's done, that's done. The negative square root of 13 is equal to, the positive square root, is equal to approximately 3.61. So you're going to plot that right here. So square root 13. That's really bad. I apologize. You're right. There we go. Then we have negative 2.5, which is very simple. So negative 2.5. Then we have the square root of 9, which is 3, because 3 times 3 equals 9. So you're going to plot that right here. I know it's hard to see, but this is how I solved it. And if you didn't get this answer, just check over your work to see if you have any mistakes, and you'll know if you have it right or wrong. Okay, so that's it for our video today. I hope we made it easier to understand the sets of numbers. So here is the end from Shannon. Alyssa and Camilla. Bye!